Hey guys, this is a follow-up to my previous video where I showed like the physical connections for the Nokia Lab, where it's going from the Nokia equipment and the Accedian NIDs to my 3550 switch into different VLANs. So now this is the actual application side of what I'm doing, what I have set up. This right here is the user interface of my um, Dell PowerEdge R710 server, or the ESXi operating system. The ESXi is by VMware, and basically it allows you to create and run virtual machines on the directly on the server. So you don't. It's basically its own operating system and hypervisor for virtual machines. So what I've done was on the ESXi server, I've created two virtual machines for this lab. One virtual machine is the actual GNS3 server, which has the Nokia 7750 virtual machines on it, and it also emulates a few of the PCs and simulates some switching and everything. The other one that I have is the one that I'm using to manage the GUI interface of GNS3 and the links between the virtual devices and everything, and that's I'm using the Ubuntu GNS3 this virtual machine to basically for the user interface. So and let me kind of show you what it looks like here. So you go in here, these are all the virtual machines I have. I only have two of them running right now. The one I have running is the GNS3 VM, which is like I said, the virtual machine that's the GNS3 is actually running on the server side of it, everything, and then the Ubuntu, which is the host that has the applications on it that you use for the user interface that interfaces with GNS3. So if I go into the Ubuntu one, I mean, I can kind of see the like a preview of what the screen looks like right now, and I actually have that screen open in another tab to kind of give you a rundown of what I've done with it. So what I have here is the GNS3 GUI, which I've created a network here. In this network I have a few virtual PCs. These here are virtual layer 2 switches. These NIDs here actually represent actual physical NIDs, like the 3 NIDs that you saw in the hardware video that I did. These represent those NIDs, but they're actually just the same as these switches here. I just changed the picture on them, and it's made to look like the NIDs because I'm using VLANs to bring those, I guess, the layer 2 information into the GNS3 topology to tie everything together. And how I'm doing that is when it comes into GNS3 through the trunk, I can actually show you what this really looks like by moving this square out of the way. So I have it in layers to hide the glue basically that holds it together. So if I move this out of the way, this is what the topology really looks like. So I actually have in this cloud back here, the clouds actually represent the NICs on the virtual machine. This one cloud right here is the trunk interface that connects to my 3550 switch. This brings in all of the VLANs that I have on the 3550 switch into GNS3, and I actually have those VLANs going to a virtual switch here. If I double click on it, I didn't mean to change the host name. If I double click on it, you can see the configuration that I have on it. So basically I have like port 0 going from the 3550. It's .1Q encapsulation, and I have it going to the other switches .1Q encapsulation as well. So basically it just brings in the VLANs and shares them out the different ports or the different interfaces over a .1Q trunk. So all of these other devices, like the ones that represent the physical devices, they're switches that receive a .1Q trunk, and those VLANs are writing on that .1Q trunk. So let me hide all that glue stuff again. So, and let me lock this so I don't accidentally move it. Alright, so these four in the middle here, these are actually virtual 7750s. These aren't switches. These are actually virtual 7750s that are in the topology. But the rest of these, like this SAS-K one, this is actually this is a switch, and this SAS-MXP is a Ethernet switch as well, and all of these top devices are switches too. So they basically receive that .1Q trunk, and if we go into the configuration of these, you can kind of see what they're doing. So if I open this up, it's receiving that .1Q trunk that's coming from the 3550 switch, and then it has two access ports. This access port is the VLAN that I have assigned to the interface for that NID. So for the TE NID, I have VLAN 22 assigned to that not to the access port, but to the network port, and for the network port I have the for the network port I have VLAN 22. For the client port I have VLAN 23. So I actually have a spreadsheet that I'm working on that kind of shows which VLANs are assigned to which ports. So like the MXP is on VLAN 3. It's basically the port that's coming in on the switch. It's coming in on a port that I have put on VLAN 3 on the 3550 switch. So, and same thing with the with these, like the GTS1 and GTS2, like the port 1 for the GTS1 is on VLAN 17, and I think that's actually going to Fast Ethernet 17 on the 3550 switch. So it's basically that port is a member of VLAN 17 on the switch. So it brings it into GNS3 on the various VLANs, and then I have in GNS3's configuration, excuse me, having GNS3's configuration, the VLANs kind of spread out and assigned accordingly. So let me close this out, and I can kind of show you another one here. So the like the SAS-MXP, if I open it up, I'll see that you see VLAN 3 is on port 1 for like port 111 is VLAN 3, and port 112 is VLAN 4, and that's exactly what I have it going to on the 3550 switch. So if I bring this back over, MXP 111 is VLAN 3, SAS-MXP 112 is VLAN 4. Now, so basically, I'm just everything connected here is connected through VLAN. So if I wanted to move anything around on the topology, if I wanted to connect one thing to something else, all I have to do is delete the link in GNS3 and link it to something else, and it bridges the VLANs together. So I don't have to move the interface on the physical equipment, on the stuff that's on the actual VLANs that are coming into GNS3. I just have to move the link or delete the link and then run it to something different in order to change the bridging of those VLANs. So if I want to connect like PC2, like instead of like going to the NID here, I can disconnect that NID by just right-clicking on the link and deleting it, and then deleting the PC2 link here, and then go and create a link here from Ethernet 0 directly to 112 on the SAS MXP. Now this PC2 is basically physically it's not really physically connected, but it's as if it was physically connected to port 112 just because of the VLANs and everything. It's not going to match the traffic, but I'll show you in a minute what that means because of the way the SAP's configured. So, but now PC2 is basically, it's got a link bridging PC2 directly bridging to that port on the SAS MXP port 112 now. So, and I could show you what that looks like here in a minute, but I want to show you what it looks like working first. So let me reconnect these the way they were. So basically I have it set up to where PC 2 and 4 are on two different customer VLANs, and on one side I have those going to this NID. This NID is basically, it's pushing and popping a VLAN tag that I have the SAS MXP putting onto an e-pipe. So basically I'm emulating a customer here that has one site down here which is switch 2 and another site up here which is switch 1. So basically this switch here at the top, I don't have any VLANs on the SAS M for the SAP on 112. I just have it the NID accepting traffic and passing it through as is with no VLAN tag on it, and it hits the SAS M and it rides an e-pipe from the physical SAS M down to the virtual 7750, and that e-pipe continues from that virtual 7750 to the next virtual 7750, and then continues from there to the actual SAS MXP, and then it rides from there to the NID, not on an e-pipe anymore because it's actually, that 112 actually has a SAP on it. So so it rides Ethernet from that port 112 to the NID here, and that port 112 actually has a VLAN tag on it. So let me show you on the MXP here. All right, so the SAS MXP port 112 has SAP with VLAN 20 on it. So VLAN 20 is facing that NID, and it's the e-pipe service ID is e-pipe service ID number 1. I'll get into these other service IDs here in a few minutes. Like these others, these are kind of playing media converters, but I'll get into that in a minute. But port 112 is the one I'm focused on right now because that's the one facing the customer and facing the NID. And that NID is being used to pop that VLAN 20 tag off and send it to the client. So on the network port on the NID, it's going to be receiving VLAN 20 from this SAP, and when it sees VLAN 20, it pops off that VLAN 20 tag and sends it to the customer switch untagged, at least from the provider perspective. I'll show you that too. So in the Firefox web browser, I could actually go in and log into the NIDs. I have shortcuts set up for them. So this is GTS1 that I'm looking at, which comes from that SAP 112 on the VLAN 20 on the MXP. So GTS number, or GTS1, is the one I want to log into. So going back to Firefox, go to GTS1, and I've already got the passwords and everything saved in there. So if I go to traffic policies, so traffic 1, port 1, what it's doing is it's this policy is set up to look for the VLAN 20 filter. All that is just a filter built on the NID to tell it to match VLAN 20. and it's I just called the filter VLAN 20. So now I go back to policies, and I applied that VLAN 20 filter to this policy. So if I actually go into this policy, it's saying like accept VLAN 20, permit that traffic. That's anything that's coming on this port. It's looking for VLAN 20 on anything coming in that port, and when it sees VLAN 20, it permits that traffic and passes it to port 3 on the NID. But before it passes it to port 3, it's taken a action here. It's that service mapping. It's popping the outer VLAN tag off of the traffic, which it's popping that VLAN 20 off of it and sending the encapsulated traffic to the customer. Or what was encapsulated, it's sending that now to the customer. So what I can do now is I can show you in Wireshark kind of what this looks like. If I right click on this link here, I can I don't know if I actually come on, I have to, there we go. So if I click on start capture, and I'll just click OK, well, it brings up Wireshark, and to show you kind of what's going on. So what I'm going to do is I'm going to start a ping from PC1 to PC2. I think it was, no, it was 192.168.50.2. Alright, so if I go back to Wireshark now, I see that I have ICMP traffic, and it's got the VLAN IDs on there. So it's got VLAN 20 and VLAN 50. VLAN 20 is the outer tag, VLAN 50 is the inner tag. That's coming from the SAS MXP, because I put that that Wireshark capture between the SAS MXP and the NID. So it's seeing VLAN 20 and 50 both on the traffic. Now after it comes out of the NID, I can put a capture on that as well and see that it only has one VLAN tag on it, because that 20 gets popped off by the NID. So let me show you what that looks like here. Let me stop that capture. And I'm going to close Wireshark, and no, I'm not going to save it. So let me start the capture here on the port coming out of the NID. And yes, I'm going to click OK. And I'm going to do another ping here. See, VLAN 20 is popped off by the NID, and now it's matching just VLAN 50, and that's the VLAN that the customer is actually putting on this traffic. They're not using VLAN 50 for the service provider. The only VLAN we have tagged on the service provider is VLAN 20. And we're using the NID to push VLAN 20 onto the traffic to get it through our network. So if you we look on the SAP, see it's just VLAN 20. It's not looking for 50. We don't care about 50. That's the customer's VLAN. The customer is using VLAN 50 within their own network. We don't care about that. We just want to encapsulate that into our service. So it becomes, once we push 20 onto it, it becomes 20.50, but the SAP still accepts it because it has an outer tag of VLAN 20. So yeah, this was the capture outside of the NID between the customer switch and the NID. And we see that in the switch, yes, it has an access port that has VLAN 50 on it. That port that we got traffic, or that we're looking at the traffic on, that one is the trunk port. So if I do a ping on the other PC, PC4, to the other side, I should see traffic on VLAN 60. So let me show you what it looks like right now. Right now I have 50, so let me ping from one of the other PCs here. We get into, actually I can do it through Wireshark, because I don't have a session saved in GNOME Connection Manager. So let me just go into C4 here and ping 92.168.60. I think it was 3. And if I open up Wireshark, see I have traffic on VLAN 60 now that I'm seeing on that on the trunk port. So we have traffic on VLAN 60 and 50, but all that traffic gets encapsulated by the NID, because if I put the capture back on the other link here between the NID and the MXP, instead of saying just VLAN 50 or VLAN 60, it would be 20.50 and 20.60, because it's the NID is taking whatever the customer is sending us and pushing VLAN 20 onto that traffic and sending it towards the 7210. And the 7210 accepts it because it has VLAN 20 as the outer tag. So I can also, so let me go ahead and stop that capture, and I'll show you what it looks like on the between the MXP and the 7750. So let me stop that capture here and close Wireshark. I'm going to quit without saving. Start capture. All right, so here we see traffic between the between the 7210 and the virtual 7750, which is just like for the service traffic, and to keep the like ePipe alive and everything, like the MPLS traffic. So what I can do now is I'm going to start a ping to show you what it looks like on this link here between the MXP and the 7750. So let me do this one, and let me do the PC1 to PC2. So now I'm going to stop that capture, and I'm looking for the ICMP. So I see the VLAN 50, and I see VLAN 60 in there as well. So here on the between the MXP and the 7750, I can actually see the MPLS headers as well, and it's got the VLAN label encapsulated inside of that. So it's got the VLAN 60 here, but then it's got the MPLS labels showing here for the and that's for the ePipe that connects the service from between the 7210 and the 7750, and then from there to the other 7210 at the top. So between the Nokia devices, we see it encapsulated in the MPLS headers, but we don't when it comes out of the SAP on the other side between the Nokia gear and the NID. So if I wanted to, I could bypass that NID and just connect this, like I showed you earlier, I could connect that switch directly to the MXP, but it's not going to work anymore because we would have nothing to match that SAP. We wouldn't have VLAN 20 to match that SAP on the MXP anymore. So if I disconnected this and deleted that, I can connect Ethernet 0 to 112, and I'll try the ping again, and you'll see it fail. See, it's timing out because it's not connecting anymore. The VLAN's not matching anymore because it has nothing to push that VLAN 20 traffic onto it. So what I could do is I could do a null SAP on the 7210, which would cause it to, which should cause it, I would think that would cause it to start accepting again, but or do a star SAP on it, but I'm not going to do that because that's kind of defeating the purpose of teaching the push and pop and everything on using the NID and why that's done and all that. But you could change it from going to the NID to the SAS MXP. I've just shown this as an example that you can move the port in GNS3 and it basically acts as if it's connecting directly to the MXP instead of through the NID. So let me actually delete that. I didn't mean to start another capture. Let me connect this thing the way it's the way I designed it now. What I could also do is I could also connect it backwards and show you what it looks like from Wireshark if I connected the NID backwards, like connected the client port to the SAP and then connecting the network port to the customer. If I wanted to connect it backwards, I could do that just to show you what an error would look like, or what it would look like if it's was actually physically connected incorrectly in error on like the technician's end or something. So if I delete this here and delete this link, I could create a link from 112 and connect it to the client port. So I'm going to connect it backwards and then connect the network port to the customer switch. Now if I do a Wireshark on this one, let me get it here, start capture. Now I'm going to try to ping from PC1 to PC2 and show you what it looks like. And it's not going to work because it's, like I said, it's connected backwards. But what's happening is the NID is accepting all traffic from that SAP, and it's coming out with VLAN 20 off of the 7210 SAP. So what's happening on VLAN, when it comes out with VLAN 20, it's actually getting VLAN 20 pushed onto it as well. I mean, it's coming out of the SAP as VLAN. Sorry, it's coming out as VLAN 20.50 because VLAN 50 is from the from this switch over here, the top switch. This is putting VLAN 50 on it. It comes through the service, gets encapsulated, and now it's going to be VLAN 20 gets pushed onto that VLAN 50 on the SAP on the MXP here at the bottom. So it's going to become 20.50, and then the NID accepts VLAN 20 because it's accepting everything and pushing VLAN 20 onto it, so it becomes 20.20.50, which really doesn't match anything from the customer, but we see what it looks like here. It's got like 3 VLAN tags here pushed onto the traffic because it's hooked up backwards. The NID's accepting all of the traffic and just pushing VLAN 20 onto it like it thinks it's going out the network port, which it isn't. It's just connected backwards. So you could kind of see here what it looks like. It's like a triple tagged frame here, which the customer is not going to be able to use that traffic because it's got a VLAN 20 as the outer tag. It's not VLAN 50 as like the customer's expecting. The customer will not be able to use this frame is unusable to the customer. So if I connect it the right way, it'll actually accept VLAN the double stack VLAN 20.50 and then pop off VLAN 20 and just send the customer VLAN 50. So let me stop the capture here, then close Wireshark. I'm going to delete this link and connect it the right way again. Oops, almost deleted the wrong thing. Delete this link and delete that link. Ah, come on, I tried. And connect it the right way this time. 112 to the network port, and then 113 to the customer's switch. And start a capture on this again, and we'll see that it's and it's hard to get this link. Right, here we go. Start capture, and we'll see that once I start a ping, there's my ARP, and then there's the ICMP traffic that's tagged with VLAN 50 because the NID's popping off VLAN 20. It's accepting VLAN 20, or it's accepting everything, and it's just popping off the outer tag, which everything happens to be encapsulated with VLAN 20 because the SAP has VLAN 20 on it, the SAP from the MXP. But yeah, there's the customer traffic. ICMP is successful because it matches what the customer is expecting. They're expecting VLAN 50 because that switch is configured with the .1Q trunk, and the VLAN 50 is one of the access ports. And that access port, it basically pops off VLAN 50 before it hits the PC, and the access port number 2 pops off VLAN 60 before it hits the PC. So it's just that port is in the is a member of VLAN 60, but it pops off that tag before it actually hits the PC. So I didn't really want this to be like a lesson on how VLAN tags work, but I wanted it to be more of like what GNS3 can do and what this lab can do with this, you know, what we could do by using GNS3 in a server. We could actually connect physical equipment to virtual equipment and see what it looks like in Wireshark, going across different links. And I know these links aren't exactly the right name. I could edit some stuff in the configuration file to make them the right way, but sometimes, like, depending on what all I change, sometimes it gets changed back, and there are little bugs here and there. Let me go ahead and stop this capture just to close what I'm doing here. But just wanted to show what is possible using GNS3. If I log into this 7750 here, I will actually see that I have SDPs set up, like between, like, going to the R2 and R8, or the 7750 R2 and then the MXP R8. So if I go to the 7750 R4, do show service using, and I see that I have one ePipe there, ePipe number 1, so show service ID 1 base. And I have an SDP, or two SDPs, I mean. SDP number 2 goes to the 7750 number 2, and it's up. SDP 8 goes to the SAS MXP R8, and it's up as well. And that's for this ePipe, and it just, in the adjacent devices have configuration for that ePipe as well to move the traffic on ePipe 1 from point A to point B, or from the SAP on the SAS MXP to the SAP on the SAS M here at the top. So, and like I said, all of this is connected using VLANs from the real world to the virtual world here. So, yeah, and it's working. I had to set the MTUs small because, yeah, the 1500 was like the max MTU I could use for the physical switch. I mean, I could have bumped it up, but it started doing some weird stuff when I was messing with the settings, so I just went ahead and changed it back and just left it at 1500 on the physical ports, just to, so I wouldn't have to troubleshoot all the weirdness going on there. But anyways, so yeah, I can bring up SDPs. I could bring up an ePipe. I haven't tested the VPLSs yet. That's one of my goals that I want to try for this lab sometime. I want to get some other stuff added, like to the left side of the network here, and I want to actually also set up to where I could build this into like a ring topology as well. I want to have it to where like I could connect the SASM XP to the SASM number 2 and SASM number 1, and put it in a ring topology and have it serviced off of like 2 of the 7750s up here, and use and try to set up RSVP and all that. But I just haven't gotten there yet. I've been trying to work out the details and work through the challenges of actually getting this lab set up and getting the virtual stuff talking to the physical stuff. Another thing I'd like to do is actually I'd like to set up to where you could RFC test from one NID to another. Like I showed you, you can actually manage the NID through the browser, because I have the management set up separately. I don't have the management going through GNS3. I actually have it going through the management ports on the physical equipment to dumb switches, and that's going back to my router. But yeah, the management is separate, because I didn't want the management dependent on me building the topology correctly. So so yeah, that's that. Now as far as the RFC test goes, I will not be able to correctly RFC test through GNS3. I would actually have to set up an external fiber link between 2 of the devices and just document where it is and how to use it. And the reason for that is because GNS3 the application has limitations on the bandwidth that can be used through these links. I actually did an iPerf test. I actually disconnected this equipment down here and at the bottom and up here at the top, and actually connected physical Raspberry Pis to the physical ports on the switch that those are associated with, and did an iPerf from one to the other, and it actually got I guess 38.1 kilobits per second TCP and 1.05 megabits per second UDP. So it's very slow, considering the types of service that we're trying to push through these things. So it's so this is basically just for educational purposes only. But as far as the RFC test goes, I would actually have to connect them externally to GNS3 so that they could be ran appropriately. They'd still be able to be managed through the browser, but the actual transport between them would be external to GNS3, because GNS3 has that bandwidth limitation. So I plan on setting that up in the future and documenting how to use it, but I'm just not there yet. I'd also like to set up some like an automation. You could probably see I have a Docker container in here for the network automation Docker container. I'm trying to learn Ansible to actually use it to reach out to the 7210s and even the 7750s and the NIDs to grab the config and save it on like on different intervals. But I'm having a lot of challenges trying to get that set up, and it seems to be a huge learning curve for that application, and I'm just not there yet. I'm just trying to learn it, but seems to be a lot to it so far. So but I will eventually get there, but that's just one of the my I guess one of my goals for this lab is to actually get the backup automation set up. So But yeah, so I've got virtual equipment talking to physical equipment, and an actual real e-pipe setup that goes from a physical 7210 MXP to a virtual 7750 to another virtual 7750 to a physical SAS MXP, and then the SAPs off of the physical SAS MXPs to physical NIDs, but it's all bridged through the GNS3 application, and it's working. It's pinging, and I could move, one port to another port through GNS3 using the VLANs that I have configured on the switches. So yeah, it's all bridged through VLANs, and it's working. So I'm sure there's a lot of questions, and I probably didn't present this the best way, but that's something I need to work on, my presentation skills. I'm very new at this, but hopefully this lab will be able to help a lot of people, and maybe we can set something like this up for our work environment and actually be able to use it to get people more familiar with configuring services and how services are supposed to be configured, so they could be able to troubleshoot what might be wrong in something that might be misconfigured, and be able to know when to use push and pop on the NIDs that hang off of the 7210s or any transport gear for that matter, and just basically get an idea of how the traffic flows from end to end on the network. So also plan on getting the documentation updated on this. The documentation that's in this topology here, some of it is out of date because I started off doing one thing and ended up doing something different. And one of the things I ended up doing different was how this SAS MXP 111 and 112 says it goes to Fast Ethernet 03 and Fast Ethernet 04 on the switch. Well, that's a lie now. I actually needed to get RJ. I needed to have some extra RJ45 SFPs, and I didn't have them. So I ended up taking the RJ45 SFPs out of port 111 and 112 out of the MXP, so I could have some extra ones, and I replaced them with fiber. And I'm using the SAS MXP as its own media converter. And I kind of said that in the video for the physical lab, and let me kind of show you what that looks like. So on the SAS MXP, we go to it. So basically what I have is so port 111 and 112 are both fiber. Port 111 actually goes to port 1111, and port 112 actually goes to port 1112. So port 111 goes to port 1111. 1111 accepts all the traffic from port 111, and it has a service ID of 3241101. Basically, as took like the I have like a SASM1, the SASM2, and then calling the MXP like the number 3. So I basically have the MXP's port 24, that's a trunk port, going to port 11, which faces port 1. So that's my kind of naming convention for this service ID. So that's an e-pipe. So that's 3241101. So it has a SAP on port 1111. The other side of that e-pipe is port 1124 on VLAN 3. So basically that port 111, it's getting converted from fiber to RJ45 going out port 1124, but it's getting encapsulated in VLAN 3. So if I did a show service ID base on that service ID, you see that it has two SAPs, of course. So it's SAP 1111 and 1124 VLAN 3. So anything that comes in that port 1111, it gets sent to port 1124 but put on to VLAN 3. And the same thing with like port 112, which is that I actually have a service ID on that on a different SAP. That was the one we were using for the pings. But anyway, anything coming from port 112 gets sent to port 1112. So 1112, I have an E-pipe on 1112 that takes everything from the 112 is sending it and puts it in this E-pipe. And this E-pipe gets encapsulated into the VLAN 4. So if I did a show service ID base on that, you see it has, you know, it's got 1112, the full port is one of the SAPs, and then 1124 is another SAP with VLAN 4 on it. So it's, and that VLAN 4 is getting sent over that trunk link to the switch, to the 3550 switch. So it's converting fiber into into RJ45 or copper. And the other service IDs on here, I'm doing the same thing for the 2 ports on one of the SAS-M. So I'm doing it for port 111 and 112, the SAS-M number 2, I believe it was. So port 111 on the SAS-M number 2. So I got it here. So SAS-M number 2 is going out of a port 24 on the MXP, but it goes out the port number 13 on the SAS MXP, or that's where the SAP is, or the untagged SAP, and then it's connecting to port 1 on that SAS M. And the same thing with the other service ID for VLAN 10. So VLAN 10 is the SAS-M number 2, going into port 24 on the SAS-M XP, which is which the other side of that is port 1114 on the SAS-M XP, which is a fiber link, and then the it's coming from port 2 on the SAS-M number 2. So that's kind of my naming convention. I'll probably end up changing that because it can be kind of confusing, which I've seen. Kind of learning a lot from this as far as like how network documentation goes and how it can be confusing, and it can when you're troubleshooting and making changes on the fly, your documentation can kind of get messed up because it doesn't quite match up with what you're moving around. So you kind of end up having to take breaks from the configuration to actually move some stuff around in your documentation to get it straightened out again in order to make your troubleshooting easier. So, and that's kind of, I guess, what we see with a lot of our engineers when they don't document stuff properly. It makes it really hard to troubleshoot, and we end up having to trace out the circuits and everything in order to find where they exist from end to end when Granite isn't correct. So anyways, I'm sure you guys have a lot of questions, and I'm sure a lot of this might be quite confusing or even overwhelming to some people, depending on what your knowledge level is to how the how these services work and how VLANs are tagged and all that. But it's something that can be learned. It doesn't take a special kind of person to learn this kind of thing. It just requires jumping in there and doing it and working these, working the tickets and asking questions, and I mean and just seeing these services, actually up and working. just seeing what it looks like on the wire, especially using Wireshark and everything. You can see how those VLANs are tagged and how the service is getting from one end to the other. But so I hope this is helpful, and I hope that we can get something like this set up in our work environment to to kind of play with without having to actually touch the production environment. So so let me know what you guys think. I mean, I know I'm not the the best person at presentations, but but I'm still learning, and I've got a long ways to go, and I'm sure that some people can give me some feedback on how to edit this video, um, and maybe some stuff that I can even add to this lab, or maybe even take away from it. But I'm looking forward to some feedback. So thank you guys for watching, and let me know if you guys have any questions. All right, thank you.